Alright, episode 2 of Learning to Arduino with me. We're gonna be going through hopefully lessons 3 through 5, and the reason we're doing 3 again is because I kind of was too impatient and like skipped through it when I thought he was just explaining the homework and solution to that. That is completely my bad. So I'm gonna go over the second half of that video, and then yeah, it's gonna be primarily the same stuff, watching the video, then pausing every now and then, working on whatever and showing you guys or trying to explain it to you. And yeah, hope y'all enjoy this video. Okay, so apparently it wasn't like to the point that I thought it was that I missed. He literally only gave extra homework after explaining everything in lesson 3. So I'm gonna do that, but I'm gonna do that like quickly so y'all don't have to spend extra time watching. And we might get to lesson 6. I don't know. Okay, and if you can see that, I did that purely to reset the board just so I can um, like get a fresh start. And I'm also not reusing the code that I used before. I want to every time I do this, I'm trying to rewrite it completely. But anyways, I'll see y'all when it's done. Okay, this is gonna be more difficult than I thought. So I tried doing it like hooked up all this, and in the video he said you need 4 pins, but I'm low key confused on that. So got that. I'm honestly so confused. I think I have to look up the answer. I'm gonna look at his next lesson. I don't know what's going on. Cause here I'm saying this as he runs through his intro. So basically I tried running everything into the same like pin and just different grounds, and that didn't work. And I'm pretty sure we'll learn why in a minute. And not in a minute, but like at some point. And then I tried plugging the ground cord into um one of the rows of the breadboard, and then plugging all of the other or plugging all the output cords into that same row. And it worked for the first one, it worked for 13, but now it's not working for any of the other ones. So I'm honestly lost. So I am gonna skip ahead. So the original the original thing he wanted us to figure out was like set all them up and then make them all blink. I can't even set them up. It might be because I haven't done this in a week. And it just flew out of my head. But I'm honestly lost because I can't even turn them on. So yeah. Okay, so I have no idea what happened. I don't know if I had to set this up before the code was able to like actually go, but I did it. And this is apparently the like messy, like not clean version, so I'm gonna get to do that. This is honestly really cool. I'm still super excited about all this. And yeah. All right. Okay, so now we're basically taking everything apart. And we're going to what's it called? We're gonna do this like super compact, is what he said. Dude, you're not supposed to go down there. Yeah, we're gonna do it super compact, and we're going to try to make it as like neat as possible. Because it being all over the place, Willy Wonka, what? Just wonky everywhere isn't good. That's how you can create problems. So yeah. That's not bad. That's pretty good. It is actually a lot neater. Okay. So while he's still going over this, one thing I think my one of my problems was the fact that I wasn't taking advantage of these bottom ones since they all connect up the entire column. Um, Instead of trying to connect all of them into that one single row that I was doing. So okay, and now he's having us change all of the pin outputs. 12, 11, 10, 12. I said that backwards. 10, 11. Which means I need to move all of these over here so they're right next to each other. And then I should be able to send this back out. Cool, it's working. It's pretty cool. Got you. Okay, so he's talking about using Bojack wires, which is like really like small ones, and they're just direct. They're not all floppy like these ones, which is honestly fine. That might be a later buy. But yeah, he's also cutting the resistors, which I'm not personally going to do purely because I don't know what I'm going to need to use what for. Because like I said, I'm trying to do like that home project and things like that. Also, again, I'm going to put in every single one of these videos I do, his playlist of all 100 videos. I'm going to put into my description. I'm going to add his account or whatever. That so you guys can go watch these yourselves, go along with me or go along with him or whatever, because I'm not really doing a whole lot of explaining. But yeah. Okay, so we just got the homework, and it's basically, I don't know if y'all saw earlier how it was doing that, like, I think it was showing how it was doing that, like, dragging along pattern or whatever. I need to do, like, a cool pattern or whatever. I want to figure out how to make each individual thing blink, which my guess would be if I do this and then do tab. Digital right. 13. Slow. Okay. I'm going to test this with just 2 of these. So now we're going to do tab, control V, tab, or no, enter digital right. We're going to go 12 low. Control V. And now I want to see if this will make the first, so this should make the first 2 blink. Yeah. Okay. So that's how you do it individually. I'm guessing you'd have to play with like the delay time and stuff like that. To get it specifically. like on time with each other, or we'll probably find a way to um do it all together or whatever. No, actually, hold on. Let's figure that out. What if I? No, it's not gonna be that. That's dumb. All right. Yeah. So, okay, that's the pattern I'm gonna do for the homework right now. And I'm just gonna move on to episode 5 or lesson 5 because I want this to be as short as possible for you guys. So let's go. Explaining how computers work based on binary numbers. Okay. So first we're going to get rid of all of this. Then we're gonna get rid of all of this. Load up that video. He's gonna do his hello guys. I'm gonna upload this blank code to the Arduino so it stops everything, and now I can take it all apart. Okay, there was a lot in that video, I'm not gonna lie. Um, but basically he essentially was teaching us about binary, and about how computers work and stuff like that. How like a bunch of or how not a bunch of how numbers make everything. He taught us how to basically read binary, um, depending on the amount of switches, like just into basic numbers. Um, so like regular counting, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The first or the farthest right digit is just 1. The next farthest right digit is worth 10. Stuff like that. Except for binary, since it all, like I said, works on switches and stuff like that, it goes by like times 2 instead of times 10. So depending on the amount of or the switches. So the farthest right like switch digit holder or whatever you want to call it is worth 1. The one to the left of that is now worth 2. The one to the left of that is worth 4. and we basically go through it as why am I blanking? I'm so like blanking right now because I'm trying to find a way to like a good way to explain this. But yeah, we're wow, this is really difficult to explain, and I also just lost my train of thought. Okay, each is worth 2, stuff like that. Worth them based on the amount of switches. Anyways, I lost my train of thought completely. But basically, I don't know how well you guys can see it. That's actual binary code, like the ones and zeros, because let's see right here. These represent 2 switches, the on switch and the off switch. How it like has that middle part lifted up. You only have 2 modes. It's either open or closed. So that's why you can't go to the second. That's why you can't go to 2 or anything. 2 or any other number does not exist in binary. It's purely ones and zeros. You either have off or on. That's essentially my grasp of it. I might be wrong, and it might be one of those moments where you like do the wrong equation but get the correct answer. So basically the first digit are, if let's say for this one we have 4 zeros. Actually, give me a second. I'm gonna set this up real quick and then I will be back. Yeah, give me 1 second. Okay, so first I'm gonna start off. He gave us homework again, and it was basically we're going to make a binary counter. So I rebuilt the thing we had from the last lesson that he gave us earlier in the video, and we're going to I'm going to help use this to explain. So basically you have the 4 switches, or in this way the lights. They can either be on or off, 0 or 1. And you can use those to distinguish numbers basically. So let's say, let me pull up my notes again. Let's say you have 0 0 0 0. Well, that's for this is the hardest. This is the part that I struggle to explain with. So 0 0 0 0 equals 0 0 for the actual, what's it called, for actual numbers with the 0 and then tens place and then hundreds place, stuff like that. So with 4 switches you can go up 15 numbers. Basically basic math. It's 4 times 4 equals 16, which means you have 16 individual number inputs that can be made with if you have, so like if you're trying to solve a lock or whatever, you have and it's a 4-digit code, and there is 1 through 4 on there. It's a 4 by 4, which means there's 16 possible answers. If there's 1 through 5 on there and it's a 4-digit code, you have 20 possible answers. And so yeah, it can go from either 0 0 to 1 5 or 0 to 15, which is the full 16 possible answers. Where's my pen? Here's my pen. And again, it can only go on or off. Since you can't double up on a switch, like I can't turn this light on twice, I instead would turn this light on and turn this one off. So let's say 0 or off, 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 off. That's 0. Off, 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 on. That's 1. This one can't become on again for 2. So that means I would go off, off, on, off. That's 2. Then if I want to go to 3, I just off, off, on, on. And you just keep doing that, where once all the ones previously are on, you turn them all off again, and you turn the next one on. Then you start all the way at the right, and you just keep working like that, back and forth, back and forth. And that's how binary works. And that's honestly, like, I love that I know that now. It's so cool. And I'm going to go on fast forward again, and probably not as fast, maybe only times 5. And I'm going to write the code because I want to at least make it so I can do. I want to do a binary counter of 1 through 10. I'm not going to go all the way to 15 because that's just a little extra. And I want to make this as short as possible. So here we go. Okay. Okay, so I got it. So now it's counting from 2. I'm gonna turn this all into 1,000 because I want it to be slower. And now we're gonna do this. This is right. That was weird. Alright. And 2, 3, 4, 1, 2, 3, 4. Okay, I'm only gonna go to 4 because that's already 23 lines of code, and I don't want to use up that much time. But I'll definitely mess with this later on by myself. Yeah, let's go to the next video. Okay, 0, 1, 2, 3, 4. Resets back to 0. Okay. Sorry, he's going through his intro and stuff like that. I figured show what I'm talking about, just in case. Alright, he's doing it like really neat. I did not do it this way. But his way's actually kind of smart. See, he's still talking, but yeah, this is the way that he did it, and it's honestly a lot cleaner than I did, which is smart. I need to pay more attention to being clean and like neat and stuff like that. Alright, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Boom. binary. It's amazing. I love that. So the next lesson is we get to do math. That's amazing, actually. I love that. And he's giving us homework. Okay. Okay, so he's asking us to add another LED. He's, I think he's doing math right now. So he wants us to have 25 total outputs. Or 25 total numbers. Okay, so I'm gonna end this video here. I think the fact that we got to lesson 6 is good. That means I'm at least getting 3 done per video right now. I'm gonna try to have another video up later this week. Hopefully Thursday, Friday, maybe. It depends. Because I don't get a lot of time to do this. But yeah, this has been like amazing. I'm loving that I get to learn not only about Arduino stuff, but like how computers work, binary, things like that, because that is really useful in engineering. Thank you guys so much for watching and being a part of this journey with me. And again, if you're interested and you like want to see some of the stuff that I end up doing with this, because like I went through a bunch of the parts in this kit. There's like the PIR motion sensor, which is like a heat type motion sensor. There's a speaker and stuff like that. So I'm thinking about like maybe hooking up like a camera somewhere like in my hallway and setting off a like not tripwire but like a little motion sensor and just making a really annoying noise just to make the people in my house like mad and things like that. That might be something that I end up posting or whatever. And then obviously I'm still in the process of designing and like obviously learning about these items of my magnetic gauntlet project that I mentioned in my in my intro video. But yeah, again, thank you guys so much for watching. If you're interested, subscribe, like my video, tell me in the comments stuff that you want to see or any information that you have as an engineer or as stuff like that, and please try to keep it as real as possible. I want like authentic information, not skepticism and things like that. And I hope you all have an amazing day. Again, thank you so much.